Hi, and welcome to a brand new video. In this video, we're going to be learning about how to solve the bitwise and problem. So in this problem, we're given two integers, left and right, that represent the range left and right. And remember, these brackets here represent inclusive. So we have left to right inclusive, and we need to return the bitwise and of all the numbers in this range. So what is a bitwise and? Well, bitwise is a way to manipulate individual bits, and bits is representative of data, and that's how your computer stores data in ones and zeros and binaries or bits. So how do we do this? How do we use bitwise in order to manipulate our bits? Well, in Java, if we put two numbers, for example, 5 and 7, what it's going to do is first going to convert it 2 bits, so it'll convert it to binary. It'll perform the operation, and then it'll return the 10 version of it. So it will return the decimal number of that binary bitwise operator. So bitwise and is just one of those bitwise functions, and we need to perform it from 5, 6, and 7 in this first example. Something to note is that when you're decreasing numbers, so if we start from 7 and then we go do the bitwise with 7 and 6, and then the bitwise with 6 and 5, then the bitwise and will always be less than or equal to. It can never be greater. And this will make our code much more efficient. Let's see how. So if we go over to our coding editor, what we can do is we can obviously start off with a for loop. Right minus 1, I greater equal to left, I minus minus. And the reason we're doing right minus 1 is because we're going to be using right as to keep track of the bit we're currently at, the bitwise and number we're at. So for example, we'll have right equal to right, uh, and this is the bitwise and operator, I. So we're going to use right to keep track of the current bitwise that we're at. And then at the end, we just return right? But here's the thing. You kind of saw how that took a little bit extra time to output, right? See, it doesn't come at the same time. And in order to, this is because this is a humongous number. So in order to reduce the amount of time this takes, we can condense our code by setting right equal to I. And the reason we can do or actually, sorry, right equal to I equal to right. We don't want to change the bitwise. We want to change I. And the reason we can do this is because let's say we have the bitwise of x and y, no, or 4 and 3. This is completely made up, and the bitwise is 2. I just said that the bitwise cannot be a greater. It can only be less than or equal to. So we can skip all the numbers from 4 down to 2 because it won't ever be greater. So we know that we won't ever get a greater number, so we can just continue from where the bitwise is because it'll always be the same or less than. So now you can see that operated much faster. So I hope this video was helpful. If you have any questions, don't feel free to leave them in the comments while I answer them. Also, feel free to leave some of your suggestions as well and subscribe to this channel. See you in the next video.